Hello all, very good afternoon. I hope you all had good lunch. All hail and hearty now. No more sleepiness, post-lunch sleepiness. So first of all, I would like to thank miniOrange for and IdentityShield for the opportunity. And my topic today, the need for adversarial debiasing in machine learning models using synthetic data for enhanced security, is at a very crucial intersection between the two most upcoming fields right now, artificial intelligence and cybersecurity. We all have heard about AI being the next big thing, and cybersecurity has been the need of the hour now. But then how do we intersect both of them to ensure that as much as how quickly we're developing AI models, are we also securing it in the same place? That's what is most crucial. And because one of the most important reasons that we are dealing today is the issue of bias. Bias is not just a social problem now. Bias in this context has become a mathematical problem. Over the course of 40 minutes, I'm going to dive you through various scenarios, explanations, and how we can eventually mitigate bias in machine learning models. So, quick brief up into who am I? I'm Aadith Sukumar. I'm right now working at Maersk as a platform software engineering intern. And my BTech is from AIML, from Symbiosis Institute of Technology, Pune. I've done my BTech in AIML with my additional minors course in security and privacy. I've also had the privilege to work at Symbiosis Center for Applied Artificial Intelligence on various advanced AI projects that are funded by government agencies, including DRDO and METI. And I'm a certified ethical hacker, and I love to research on AI security. I also published a few articles and papers as well. So let's get to the overview context of why is bias so important nowadays and what are the harmful effects of it and everything. Then I'll share two of my projects that I've worked on to get you more insights into what actually goes on behind these projects. And every story needs a connecting point, right? So we'll be going through the entire journey with a very, very wonderful story which you might have heard of. That is the bullet hole conundrum. How many of you have seen this image ever and know what it is? Right? So what happened in World War II is that a lot of researchers are figuring out how to reinforce airplanes that are coming back from war. The problem is when they assessed the planes returning back, they figured out that there were multiple bullet holes. The most logical solution was that we should enforce these areas and make sure that these areas are strong because they're getting massively hit. But the major mistake that they found out was done by a statistician called Abraham Wald, who argued that they should reinforce the areas which are not being hit by bullet. And why? I'll come back to the same slide very, very soon. And let's jump onto the very basics of machine learning and bias yet. How many of you are from a non-AI background? Non-AI machine learning background? Wonderful. Then I'll just give a quick overview onto what machine learning is. It is very, very simple. In simple terms, a machine is basically involving data and a model. With a model, we feed data to the model and it learns patterns without it being explicitly programmed. It learns the various patterns that are there, the underlying scenarios and the nuances, and eventually it helps us to build a lot of predictions and classifications. And ML is being used in various other words. The words are more used very interchangeably. Machine learning, AI, deep learning, neural networks, they're all used interchangeably. But they all focus on one thing. It's fundamentally built upon data and the model learns from patterns. So machine learning is not thinking on its own. We are feeding the data to it. And that is why we have to be very, very careful, because if the data we feed into the model is biased, it is not the model's fault. It's our fault for feeding biased data. And that is where we need to be very, very focused on. And for example, this is how machine learning works. Let's say there's a child and we show them a picture of a cat and a dog and we tell them this is a cat, this is a dog. And we train them multiple times. Eventually, when I just show them a picture or show them a cat or dog without telling what it is, it would be able to give an outcome. Okay, this looks like a dog, so this is a dog. Right? This is the most simple way of how machine learning works. Now coming to what is bias, the most crucial part. It's not like how we say, oh, this person is biased, they're having a very biased outtake. Very similar, but in terms of machine learning and AI, it's a different way. Now imagine for the same child, we showed it what is a dog and we showed photos of these golden retrievers and Labradors and told, this is what a dog looks like, this is what a dog looks like, this is what a dog looks like. And then if I suddenly showed the child a picture of a husky or let's say a pug, it's going to be very confused. It's like, wait, the dog doesn't look like that. That's what it looks like. Even though this is also a dog. It's because we have only trained the child the dog has to have these particular features. This is the fur coat and color. That is where the entire bias turns from. And we can't blame the child, right? Because bias, data diversity is very crucial if you're training the child. Now, again, this is a very, very simple toned down analogy for how to explain bias and MLs. So coming to the next step of how actually dangerous can bias be. In the context of AI, we can call it like an unfair prejudice that is being given to a model. AI powered systems are trained on specific data. And only if those data are very strong, balanced, and robust, will a model be able to generalize. That's the most key word for every AI model out there. How generalized is my model to work on various settings? Right. So let's take an example of, let's say, for a financial model. It is trained on a lot of user data, but if the data is skewed towards one particular nationality, income source, sector they're working at, or their gender or age, it can be very, very skewed. Or if they grew up from rich, from a very, let's say they have generational wealth, and a person who's new into the field does not, then the banking model might be biased to any new instances for people coming. And there have been multiple cases of these. We'll go through the case study as well eventually. So we've already seen various facial recognition biases happening all around the world. It's not a new thing that's been going on for the past 5 to 10 years, I would say. Let's say there are headlines like these. Google has apologized for missing the mark, biased and wrong. And then it's also going towards various other automation sectors and not just facial recognition. There have been various campaigns such as the Algorithmic Justice League. There's a documentary called Coded Bias on Netflix, in which you can understand how this bias actually affects people. It is not a simple spectrum as to, okay, this model wrongly classified my face. That is so offensive. That is not the main reason over here. At some cases, in these surveillance efforts, these models have also seen and given life sentences or death penalties, which can potentially harm someone's life or career, just because of a misclassification by an AI model. So that proves that how much can we trust an AI model, and how can we secure it? And of late, it has been transitioning from various other locations. First, there was a bias discrimination against people in the West. Now it's slowly moving against Asians and specific ethnicities and so on. So how do we tackle these bias is one of the most important thing. We cannot eliminate this bias overnight. We cannot retrain all the models to make it run overnight. But it has to be a gradual step that if we can form it now, by the time we have proper AI legislation laws in place, humans can be equally existing with artificial intelligence systems while not having so much prejudice or fear against AI systems. As we move forward, let's understand how these biases take shape and how at a very data level, how these biases can creep in. So what is mainly the potential of AI bias in critical infrastructure? The first one is the facial recognition system. So certain data sets favor a particular ethnicity or model or a particular people. That is where facial recognition comes into place. This has been predominantly more active in other countries like Europe and the US, where they're facing a lot of bias to a certain race of people, right? The next one is the cyber attack detection. A lot of incomplete or data sets are used on very benchmark levels to train these cybersecurity models. It could be at preventing, let's say, building a firewall, or it could be a honeypot or various other sectors. If the cyber data patterns are not equal or balanced, it could lead a breach in cyber attack detection. And I'm not sure, there was a session yesterday where it was told that as the bad guys are getting more sophisticated with AI, it's time for us also to get sophisticated and improve our defenses with AI. That is where the adversarial part comes into play. As the attacks improve, we must improve our defenses as well. Third is predictive policing, which is very similar to how facial recognition systems work, is where laws or any kind of judgments cannot be taken due to an AI model. And the next step is automated hiring systems. This is something even I have had a very close call with right after completing my graduation, is that a lot of these hiring systems are focused on a type of people or group of people. And because how the employees are there in the company, employers usually tend to see people who fit into the work culture. So it's not just the work culture or the skills, but you need to figure out how it also manifests in various forms. There are a lot of companies which do a parsing of the resume very first. The very first step is they scan your resume, they filter your resume. Many a times they use AI models to filter your resumes, and then they'll select, let's say they have 1,000 resumes, they filter the best 250, 300 to go to the next round. But how sure are we that those filtering models for AI hiring are completely safe? That has become one of the most crucial structure of it. Then the third most important, then the next point is autonomous vehicles, where a lot of these cars nowadays, you might have heard of this technology called ADAS or FSD, full self-driving. Many of these data sets are actually trained on very simulated environments, which is not safe. When we train our autonomous vehicle driving, be it any kind of self-driving car or a lane keep assist, basic semi-controllable car, if those vehicle models are trained on very ideal situations such as daytime, very clear sky, visibility everywhere, then that can lead to adverse scenarios where the car or vehicle is not in the most ideal scenarios. During a thunderstorm or during zero visibility, there's heavy fog, heavy snow somewhere, or during nighttime. There has been instances where multiple autonomous cars have failed to identify or properly recognize pedestrians or animals. It was trained on detecting pedestrians, but it failed on certain animals. It was able to capture certain animals, but it failed on other animals and some pedestrians as well. So how are we training these autonomous vehicle models across various diverse data set is what will make a difference to build a robust model. Then comes the healthcare security systems. Past patient records are also used to create AI models and ML models to predict what could be next, be it for insurance purposes or for diagnosis. But at times, we cannot ensure that every single illness or any kind of healthcare requirements can be generalized. There needs to be multiple sectors and scenarios where we need to focus on the patient's history or the culture or the region the patient is from. People from one particular country or continent can be more and more vulnerable to a specific type of illness or disease than people from another country or continent. That is the most important thing we need to work on. We cannot have a singular one size fits all, especially in machine learning or AI. And even though we keep talking about generalization, having a generalized robust model is not the same as one size fits all. We need to ensure that we're having a balance everywhere. And then comes the most last point, voice recognition systems. This has also been pretty much used in security scenarios where voice can be manipulated or the voice is not trained properly. And that's where AI bias can come into play. This recently, not recently, I think it was about 5-10 years ago, when Apple launched the Face ID system. There were news that twins could unlock each other's Face ID or the Apple iPhone with that. That posed a serious concern. But hope it's now fixed at a much more better level. But then, as we say, as the good guys keep on improving with sophistication, so are the attacks also increasing. So let's go on to the big problem of bias right now. It's way more dangerous than it is because bias can be broadly defined as the results that oversimplify things. We cannot have AI innovation unless we have a balance in training a model, right? So that is why what happens is a lot of these benchmark data sets are unfortunately not balanced. So we need to balance them because the most important thing is that bias is not a very demographic bias or the colloquial way of saying bias. It's more of a data problem. It's a change in distribution that can have a lot more unintended consequences. And that makes things more dangerous. So then coming back to the bullet hole conundrum where we saw that the paths were not reinforced. The reason was that they were only analyzing the surviving flights. The surviving flights had bullet holes and they thought, okay, here's where it got hit. What they missed out was the regions where it did not hit in the returning flights were the regions that were hit in the flights that did not make it back. If the flights did not return, that means those areas were hit, where there were no bullet holes. So that was the problem where this could be due to the lack of unseen data. They didn't even see the data. How can we assess something if we don't have the flight back? And that is where the most famous or the most key word for every entrepreneur in 2024 comes into play, generative AI, or let's say synthetic data, right? So this again, what is generative AI and why is every organization jumping on the bandwagon in Gen AI? Everybody's talking about Gen AI. You take any product, it's Gen AI, Gen AI, Gen AI. But then what is exactly going behind there? It's a very simple term called as generative adversarial networks or GANs. The adversarial part here is basically the GAN networks keep fighting with each other. It consists of two models. One is a generator and one is a discriminator. The generator keeps generating new data and the discriminator tries to say, no, you are a fake data or this is a real data. This looks real to me. Every time the generator is defeated by the discriminator, the generator improves itself to generate data which are more realistic. And then again, the discriminator tries to identify it. So it learns to generate more objects that look like the data it was trained on. And since Gen AI is able to get us so much of data, and it's also able to automate a lot of tasks, various organizations are using it to save time and resources for business and organizations. That is why there is a huge potential for AI to disrupt the significantly wide range of industries, right? So how many of you have heard about these companies who are spearheading generative AI? We've heard about them, right? Companies like OpenAI, Nvidia, Anthropic are all leading right now. We also had research-oriented companies like Facebook AI, Meta, Microsoft Research, Bear Research at Berkeley, IBM Watson, and more. These are the companies spearheading these generative AI results. But then the actual target audience is way more than we can imagine. There are so many companies leveraging this AI, generative AI, for every single minor tasks, be it from text, image, audio, code, chatbots, video, ML platforms, search engines, gaming, and data. There is generative AI which is penetrated into every single sector today. And because there's so many diverse sectors, the scope for things to go even 1% wrong is very, very high over here. That is why we need to ensure that there is a lot more security in place for all of these data. So coming to the main part where it can help us, synthetic data. As I told how GAN is the generated adversarial networks, synthetic data is the generated part of the generative adversarial networks. It is artificially created data that mirrors real world scenarios. So it looks very, very similar to it. There are various websites, so you might have seen a lot of these reels coming up where the concept of deep fakes. Deep fakes is one of the most prominent example of generative AI or synthetic data being misused also right now, I would say. It can be used to create bigger, smaller, fairer, or more richer versions of the data. And the benefits of synthetic data go way beyond just privacy, because we can also use generated data to train models much more in a better way, right? And by 2030, a Gartner report suggests that the majority of the data that we use for development of AI models will be synthetic data, because we have found out that acquiring real data has become more difficult, and real data has been seeming to have a lot of bias in them innately. It's difficult for us to process it and balance it out. Synthetic data is providing to be the right catalyst for us to ensure that our model is trained on a very diverse and balanced, equitable data. That's why the need for synthetic data is also skyrocketing at this point. And this is also a major case study for how generative AI is impacting various businesses. So we'll be going through the various techniques that we can use for the development of debiased ML models. And the first thing is using bias mitigation by pre-training, right? So pre-training is like setting the foundations of a building. Before we start the building, we start with the very base foundation. So to ensure that the roots are strong, in this case, data. The first method for pre-training is by using a balanced data, where let's say we can undersample the majority classes or we can oversample the minority classes. So if you find too many images or any particular data, we can undersample it. For example, let's say I'm showing the picture of a classification model. I have 5 dogs and 1 cat, and I'm putting this to classify. There is a major data imbalance because you can see the ratio of it. The cats, there's just 1 cat across 5 dogs, and this is just a very minor toned down example. And our classification model will not be accurate in detecting this. So how I can mitigate this particular problem is by using generative AI and creating more synthetic data. So I can have a generative model which will generate me 4 more images of cats. Again, the number is just as an example. We deal with nearly hundreds and thousands of data points. Here, so now we can have an equal class balance and ensure that, okay, our classification model will be much more similar now. But again, this is just a problem of misclassifying cats and dogs. Imagine this same case applied to humans for classifying humans based on their income, based on their nationality, based on whether they should, what kind of judgments should be given to them at a surveillance level, policing level, financial level, healthcare level. The problems of misclassifications are very, very large. Then comes the next step, that is by using data augmentation. Not every company or every organization have the entire money power or manpower resources to utilize generative AI or synthetic data. What we do in that case is the technique is used in very, very low resource environments where we can modify the existing data. Let's say we have the same 5 dogs and 1 cat, and we do not have access to generative AI or some sort. We can use data augmentation to ensure that the same model has been interpreted by the model in a different way. So then for this model, it pretends that, okay, these all are different cats and I have a data balance now. So this is a way where we can secure models or debias models using synthetic data at a pre-training level before we even start training the model, right? So that's an overview of both the pre-training models using balanced data or data augmentation. Then comes the next part of it, where we can bias mitigation by in-training. During the model training process, there are 4 major ways to ensure that our model is debiased properly. The first way is domain discriminative training, wherein we are telling the model to focus on specific parts, give more attention to specific data points, so the model is unbiased. This is also known as fairness through awareness, wherein we are saying that through the account of decision making, the bias can be reduced because I'm telling the model to focus more on specific minority classes so that it is not being overshadowed by the majority classes. This is one particular method of it. The second is called fairness to blindness, where I'm telling the adversarial model to actually avoid certain crucial aspects or features that could lead to a bias. For example, when we spoke about the hiring process AI, right? In the hiring process, let's say that the company is filtering or creating a model based on their existing employees. And they have the entire data of their employees given to the machine learning model. And the model is learning every minor details, including the first names or the names of the employee, the blood group, or what region they're coming from. The model does not need to learn these facts. Because what happens is, let's say a company has a lot of people from B positive blood group, or a lot of people coming from a specific place like Mumbai or Delhi. The model learns that, okay, the ideal employees in this company have to belong to this particular blood group, or this particular region of or location, or let's say this should be their first name. Majority people have commonly this name. It learns to think that, okay, maybe the company wants people like this, but that's not true. Companies will hire based on merit and skills. So instead of specifically focusing on, let's say, what kind of skill sets or what kind of project the model has learned, it ends up learning additionally unwanted data, which will creep into machine learning. So even if a person has the skill, okay, very good. I think the AI does not like this. We cannot go against AI. So what's happening is that because of the fairness through blindness, let's say a particular employee has good skill sets ideal for the company, but just because of his particular his or her blood group does not match the ideal scenario in the organization, they might get rejected by the AI, which is a very big bias problem. That is where fairness through blindness comes into play. We deliberately tell the model, hey, don't focus on these parts, these are irrelevant. You only need to train yourself or learn yourself for ideal employees through these skill sets and projects. Then comes the third part, where we talk about domain independent training. So what happens in domain independent training is that they strike a balance between the first two, to be honest. It learns what is specific in a particular domain, and then they could learn from the what and the who. Shall we continue? Okay, cool. Wonderful. So basically, this is also used in facial recognition systems where we can learn through various genders or particular domain what is best suited for. Right? This problem has to be mitigated for, let's say there was a report which said that most number of chefs are men, but it had a bias where it said in a household construct, most of the people who cook are women. This is a major bias that creeps into play, that no, women are more focused on household centric chores, while if you're in a restaurant, then the chef has to be a male person. This is where a domain independent training has to come into play. Then the last method is the domain adaptation methods, wherein data from one particular domain, let's say healthcare or defense or business, certain facets of it can be also applied to any other domain to ensure there's matching similarities. Right. So that is where it takes into multiple domains which are more biased or less biased. And then they integrate it within the AI models to detect intrusions from around the world across various channels. So it makes itself more robust by learning from more robust and less biased models. So it's more of like a hand-in-hand training. You help me, I help you kind of a method. So in training, mitigation strategies are all about refining the model's thought process while it's getting trained, that it should learn in a specific way and it should not give any biased metrics. Then comes the third method, that is bias mitigation by post training. Let's say we have trained our machine learning models and then we have to now mitigate the bias in this. An example could be, let's say that there's a student who is, well learned and extremely topper of the class and everything, but then over the course of day he picks up some bad habits. That blinded me. So the student has picked up a couple of bad habits along the way, but then how do we fix this now? We cannot retrain the student. No, you have to go back to grade 1 and then do all the 10 years together. That's where in post-training methods comes into play. The first step is called random perturbation. This happens wherein specifically we are giving small random tips to the model that, hey, this is where you went wrong. Why don't you learn this part as well now? Where this saves time is that when you're dealing with large number of data and models, training an AI model might take hours and days. it's not feasible to keep on retraining AI models. It's going to take a lot of computing resources. In this place, bias mitigation by post-training comes into play, where we feed small data or tips into the model to correct it on the end of the production. Then comes through the method of layer-wise optimization, where while the model is predicting the outcome, we tell that, hey, wait, at this particular layer, I think you're making a mistake. And the major concern with this particular problem is that most of the AI models are called black boxes. We do not know what's happening inside the model. We just see the input, we give the input, and we get the output. We don't know what's happening in the middle layers. But through, let's say, layer-wise optimization, we can break down the model, identify where exactly are things going wrong, and then rectify it at that particular point. Then comes the third and most powerful step, is where adversarial fine-tuning. This happens where we have another model called as the discriminator to now predict whether whatever our model has trained is correct or not. So this is very, very I wouldn't say efficient, but then it is very cost intensive. This needs a lot of computing resources because you have to run two models parallelly. One, which is your actual model for your business use case. And then secondly, you have a discriminator model that tells you how biased or not biased your model is. This is said to be a very, very efficient model, but again, there's a lot of trade-offs over here, right? So coming back to this of how does these model biases even arise? We can do a very simple correlation over here, that we missed out on crucial parts. That is why we are having a bias. What if while training our models for healthcare, finance, defense and everything, we missed out on crucial parts too? That is where it comes into play, wherein we cannot be just analyzing the survivors or whatever data we have. We need to take the overall picture when it comes to debiasing models. For instance, let's take a cybersecurity model which I'm focusing on mitigating DDoS attacks. I'm only learning from benchmark data where I know, okay, ideally this is what a DDoS should look like. Or this is what a clean traffic is like. Where my traffic is smooth, there's no problem anywhere, my systems are up and running. Or let's say in a facial recognition system, where a model is being trained on stock images, a stock image of how a happy person will look like, how a sad person will look like, how an angry person will look like. But on a real life scenario, they may not replicate the most ideal stock footage. You've seen those stock footage everywhere, right? It's not very ideal. This doesn't look like a real person at times. That is where these two factors come into place. Because nowadays, a lot of obscurations can be used in facial recognition model. If we are looking to catch a particular criminal using his facial data, all he can do is, in those like those old Indian movies where the villains would shave off or add a fake beard and look like a different person and stuff. That is where this comes into play. So the two case studies we have learned, the first one was bias mitigation in facial emotion recognition systems, where you realize that a lot of these models are trained on stock footages. And there's a big impact when it comes to actually putting them for various domains such as security deployments or healthcare deployments. So that is where these biases hinder the real world applications. And how do we mitigate it? Is by having a twofold method. First, we identified the good image bias, and we added our own synthetic data into the model. And then we trained the model once again to ensure that the bias has improved. For example, this was an experimental proof how our model was trained on different synthetic data. You can see every single ethnicity, race, time, obscurations, wearing a hat, wearing sunglasses, having makeup, not having makeup, different ethnicities for various emotions. When we are able to generate such data using generative AI and we retrained the model, we figured out there was a very much significant increase in how the model was able to classify people. In 4 phases. First, we had a baseline ML model with stock footage. Then we used generated synthetic data and inferenced the baseline model and figured out that our synthetic data was not correct the model was not correct when run on synthetic data. On real stock footage, our model is performing amazingly well. It is performing a sad person as a sad person, happy person as a happy person. But when we use synthetic data to add various obscurations, our model failed. Then we mixed the data and we retrained the model. And when we again inference the data, our ML model could work on a much better scale. That is where we were able to see results improving at a very major level at every single emotion and steps. Some steps could not focus on specific emotions, but that can be improved through various more synthetic data. The second most, where you say bias at its core does not necessarily imply about our view of human bias. Data bias is a much more bigger question over here. That is where we come through adversarial debiasing of machine learning models for enhanced network security against DDoS attacks. So in this particular project, we figured out that a lot of these firewall systems in place were trained on benchmark datasets with common attack patterns while underrepresenting the safer ones. With the advent of generative AI, bad hackers are also able to simulate what looks like a very, very real, clean data, but having that attack to breach various ML models or firewalls in the place. That is where we were able to misclassify any kind of normal firewall model using synthetic data. We used a similar method to again break it down, where our solution was to leverage adversarial training through mitigate bias. We figured out that the generated synthetic packets were done through GANs to make the model more robust and better. And then we adapted these models to work effectively in various diverse network situations. For data analysis, our benchmark data was based on the CIC DDoS 2017 data, which had more than 200,000 rows across 50 features. Then for synthetic data, we trained our own in-house GAN architecture, and it was again trained on more 100,000 rows with same 50 features. And we used 12,000 of those for our experimental setup. Now, what's crazy is that when we had this total number of data, we had nearly dealing with 11.8 million data points for this particular project to ensure that our network model is more robust. And when we talk about networks, 11 million is hardly anything. That's like per day we are generating billions of traffic and patterns. But through this phase-wise manner of how we are able to logically make the models more unbiased, we were able to figure out that even a small change in making those models more secure led to a much more drastic impacts. For example, when we again retrained the model and tested using our final data, our inference score improved. Our results when we performed were, at the baseline model, we were able to achieve 99.96% accuracy with normal baseline data. But when we use generated DDoS packets to breach or break those models, it gave only 50% accuracy. It was just hitting a fluke that this might be a DDoS or not might be a DDoS. When we retrained our model, our accuracy went from 99.96 to 99.98% accuracy. And then when we inferenced much more stronger DDoS packets, which looked very similar to safe ones, it had an improvement in accuracy by more than 20%. And this 20% might seem like a smaller number, that, oh, it's just a 0.2% increase in the training sets. But that itself is like equal to just hundreds or thousands of packets. But imagine when we're dealing with billions of packets, the amount of data we are actually ensuring it's safe goes in millions when you're talking about billions. That is where ensuring network comes into a very major phase. So what are some best practices and future directions and conclusion? Is first talking about ensuring that the data set is curated. We need to ensure that we have diverse and unbiased data sets. That is the most crucial part. And secondly, incorporating inter-annotator agreement. Has anybody heard about inter-annotator agreement here? No? So what happens is, in various contexts, let's say, for me, what do you call spicy is very different from you. You have a different meaning for spice. My happiness is different from each other. So how are we bringing various cultural agreements to ensure that we have a generalized aspect is what is inter-annotator agreement. This improves the cultural differences for various models, right? So every culture has its different way, and we need to ensure when we have a more robust model, we should build a more non-linear data. Then comes during the model training, where we employ adversarial and domain adaptive techniques for enhanced fairness. And at the same time, we refer to model cards before using pre-trained models. A lot of places like Hugging Face, and we get a lot of pre-trained models over there. But we need to also check how safe are these models, what were these models trained on. Third is for bias auditing, which I find a lot of companies overlooking, is we need to also audit the bias in our ML models. If our organization is using AI or ML somewhere, we need to have a routine checkup of how we can evaluate those models. And last is a deployment consideration, where apart from a normal CI/CD for development, we also need to ensure that our models are continuously monitored for any change in ML and AI datasets. We can see that ChatGPT trains reiteratively with the own data we're talking with. Is this happening for our model as well? I don't want the users to feed malicious data and then make my model retrain wrong data. That is why we need to have a continuous deployment for it. The future directions for this have three main purposes. First one is dynamic adversarial threat mitigation, where we need to ensure that these robust models can also work in real time. Where in real time, we can not just predict any DDoS attack, but any potential zero-day attacks as well. Then comes the next step of using much more enhanced synthetic data generation. GANs and Gen AI is improving at a daily basis. You must have heard about the old video of Will Smith in a generative AI context where it was very poorly generated. But then that same Will Smith video was used to ensure that every other model is more robust. And now we can't even figure out what is real, what is fake. That is where generative AI needs to get more better at. And third is a concept of explainable AI or XAI, which is in trends nowadays, where we need to understand how are these models coming to a particular decision. We cannot just blindly trust a model. I would like to know what's happening inside the black box to make sure that, okay, I am secure and safe now. I know what's happening and why it is happening. That is where having explainability in security models is very important to avoid bias. And even if there's bias, we can pinpoint and fix at that particular step. So to wrap up of what we have learned so far is that bias in ML can leave blind spots. There are a lot of ways to focus on a particular thing. We can combine adversarial debiasing with synthetic data augmentation, and we need to continuously monitor it. And last but not the least, adversarial debiasing it's not just about, let's say, enhancing model fairness. It's also about making sure we build resilient and secure systems that for a longer run will protect critical infrastructures and ensure a safer digital sphere for all of us. Right? And that brings to the end of my talk. Thank you very much. I'm Aadith Sukumar, and you can scan for my... You can open the floor for any questions. You can follow me through this link. You can also give a feedback over here. That'd be very helpful for me to learn. And the floor is open for any questions.
So, am I audible?
Yep.
Yeah. So when we talk about synthetic data, right, in terms of the AI should enable to segregate between facts and the synthetically generated means fed data.
Correct.
Right. So, for example, if we are asking something about the facts, it should not give the synthetic data's information as a facts.
Definitely.
So how it does that?
So when we're dealing with, let's say, something of a fact check or a real news check, then in that case, we need to ensure a lot more real data is in picture. Obviously, we cannot have synthetic data. As I said, there's no one size fits all. So this could be one particular exception where we are segregating what is real news and fake news. We cannot train our model using generated synthetic news. So we cannot have a one size fits all over there. So there are some exceptions such as the real fake news ones. But where we can get better is that we can, using synthetic data, we can deliberately create more fake news and tell the model this is a real news and this is a fake news, and now learn between what is real and what is fake. So we can use fake data to generate fake news because we won't have real access to fake news. There's no real fake news. That's a contradictory statement in itself. We have real news or we have fake news. When we don't have fake news, we can use synthetic data or any kind of generative AI to generate fake news to train the model better.
I have one more question. So, for example, when we are giving synthetic data, right? When we are collecting the real data, there are laws like there are different laws that HIPAA and different laws come into play. When it's synthetic data, I don't think those laws will be applicable, right?
Exactly.
And it will be far much easy for AI to be like they can be trained easily rather than.
I agree with the point. The thing is, every organization has to go with the data policies or the GDPR policies that has to go through. We cannot just directly use data everywhere. That is why I also mentioned that by 2030, probably most of the data we are training our models with will be through synthetic data, because there is no exploitation of any PII or SPIIs over there. There's no personal identifiable information that can get leaked. What we are having is synthetic data or fake data, as one might say, to make sure that these models are more robust. So yes, that's a good foresight where we can actually have more synthetic data than real data, just because of the more stringent data laws that are in place. Thank you. Anyone else?
So as you said that we can train the models for AI models specifically, and one point that I saw in a PPT was that we need to see how the data is being processed and what outcomes are coming.
Yeah.
For example, I'm taking neural networks into consideration as an algorithm for machine learning. As you know that in neural networks, for every node, it is using an activation rule.
Correct.
To process the data and generate the output. So are there any methods in different machine learning models through which we can assess that so that we can get the correct answer, or we can identify that how the data is being processed?
So looking for a metric as to how are we understanding the data processing?
Not a metric, but understanding that at each and every point or at each and every node of any model, let it be random forest, let it be SVM or anything, when we are training it with synthetic data or real data, then we can evaluate that how the data is being tracked. Like what is
Yeah.
the flow and how the flow of data is being considered.
That is where there's more emphasis on XAI, explainable AI. So there are methods, let's say, when we're dealing with images for a particular example, there's a method called as GradCam. The GradCam method, we can apply the GradCam process. Let's say we break down the model, and in between layers, we add our GradCam networks. And we can, it's more of like a model checkpoint. Every checkpoint, we are seeing, okay, by the fourth step, the model is giving this much results. By the time it reaches to the seventh step, it's getting this much results. So there's a visual way to also identify, and that can be done through explainable AI methods. There are methods like GradCam, Lime, and so on.
Thank you.
Yep.
So I think one of the slides says we should be enabled to detect the zero day attacks, right?
Mm-hmm.
So because there is no data, right,
Exactly.
about the same. So how to train them to detect it, like those types of attack? There is no like probable data over there to detect those attacks. So how we can train those?
In definition, you're very right, because we cannot have what is zero day attack, because we would not know. By the time we know, it is no longer zero day attack. So a method that we are actually working on right now is using a method called as inverse reinforcement learning. That's a method. It's you might have heard of reinforcement learning in various contexts. How any kind of model is learning to play chess, or is beating chess masters and using a game of Go. In inverse reinforcement learning, we can backtrack the potential steps of what would a zero day attack look like in the past. What was it like? So let's say in the past we had a specific zero day attack. How did we resolve it? Why did we resolve it? How did it come to it? And where did it all start? So using a inverse reinforcement learning pattern, we can ensure that models are learning how these actually work. So that's a thing in actually study right now.
Thank you very much.
We had this question from one of the overflow rooms
Mhm.
that how to improve the matrix such as FID score of adversarial GANs, especially in cybersecurity domain. Example, malware generation.
How to improve the metrics.
Yeah, such as FID score.
FID score, yeah, in malware detection metrics. Okay, that's more of a straightforward answer for this. The more robust your data is, that's how your metric will also be similar to. And what people also miss out is it's not just the data that has to be secure, but even the model, the architecture we are using is able to learn the data properly. So when we are looking to improve metrics, the FID score, let's say in a context like improving malware classification, we can use those existing data and ensure it's more balanced, and also fine tune our architecture a little bit much better in neural networks to ensure that there is no bias or any misclassifications happening there. Yes, that's it. Thank you very much. I am Aadith Sukumar, and I hope to connect with you soon. Thank you.